We will solve this today's LeetCode problem. The question is count number of teams. The question is LeetCode medium. Let's see what the question is asking. So there are soldiers standing in a line. Each soldier is assigned a unique rating value, and you have to form a team of three soldiers amongst them under the following rules. The first thing to note is that the we have given a unique rating, right? We have given a unique rating value, so we will consider that. Also, we have given three soldiers with index I and jk. We need to choose three soldiers, any three soldiers with index ijk, and whose rating is rating ijk, and a team is valid if this ijk is strictly increasing, rating ijk is strictly increasing, or rating ijk is strictly decreasing for all the values of ijk between 0 to n, right? And we need to choose three different three unique indices, right? So we need to return the number of teams we can form with the given conditions, right? Soldiers can be of multiple teams. What means a one soldier can be part of multiple teams. So how many teams we can form with the following conditions that team is valid, right? How many team is how many team we can form? That's the question is here, right? So first thing is that rating should be can be increasing or decreasing, right? This is the conditions, and we can choose three ratings at a time. Three ratings we can choose. We need to choose, right? So one thing is to clear that we can form any we can take any three ratings, right? We can take any three ratings. So if we see here 25341, so let's talk about increasing, right? Because there are two things, one is increasing and one is decreasing, so we need to handle both separately, that's for sure, right? Because we can't handle the same both of the increasing and decreasing at simultaneously, because both is different conditions. So suppose we are handling increasing, right? So here we have started from 2. So 2, 3, 4, this can be possible. 2, now again the only 2, 3, 4 is possible, right? You can see that other than this 2, 3, 4, we can't have any three distinct integers, right? Now for decreasing, you will see that 5, then 4, and then 1 is possible, right? 5, 4, 1 is possible. Also 5, 3, 1 is also possible, right? 5, 3, 1 is also possible. So if you see, we have decreasing 2 and 3 possible, right? So by this example you can see, by this example you can see that you can see that each ratings can be a part of different teams, right? Also, if you want to do it by brute force, right? If we try to do it by brute force, how we will do that, right? So basically what we do, we will start from 2, then we will check for every number after that 2, at whether it is whether we have previously a decreasing or increasing number, and then we will check for each and every number, right? We will check for each and every number. But for that, the problem is that if we check for each and every number, the first number is that you will start from each number, right? And if you start from each number, you will check for each number that whether this has a second count or the third count, right? So, and the hint which was given here is something is not possible, right? If something is not possible, that brute force is check all possibilities. But if you check all possibilities, then this will give TLE. Why I'm saying that TLE? Because if you try to use brute force, first what will you do? That we need three ratings, so you will choose 2, then you will choose again 3, then you will choose 4, right? Because for trying all the possibilities, you you need to use you need to use recursion, right? You will use recursion for that, right? You will start from each and every value. You will start from 2, then you will start from 2, then you will start from 3, you will start sorry, you will start from 4, 5, you will start from 3, you will start from 4, you will start from 1, right? So this is 2, then again this is just for increasing, right? The same thing goes for decreasing purpose, right? The same thing goes for decreasing. This is for increasing, I'm solving for increasing, and the same thing, just just a sign, just a sign value is for decreasing, right? So when you do for increasing, and if you will start from 2, you will check for 5, right? Whether this 5 is 5 can be possible, right? 5 is possible because 5 is greater than 2, right? So what we need to do, we will see that the 5 is possible, right? 5 is possible. Again, for you will see 3 is not possible, 4 is not possible, 1 is not possible. So 2 5 is possible, but this is not 3, right? This is only 2 teams. 2 5 is only a 2-member team, right? Then you will go to 5, you will check for again increasing, for you will check 3 4 1, because 2 is already checked by this, right? 2 is already checked, you can't check because we are checking increasing, right? So if increasing you will check, you will see further elements after 5. So 3 4 1 is not any, not anyone is not greater than 5, so we will leave that. You will check for 3. If you check with 3, 4 is available, 4 is greater than this 3, so 4 can be value. But after this 4 there is no value which is greater than this 4, so this 3 4 is also a one member thing, right? Same for 4. When you check for 4, there is only 1, and for 1 there is nothing. So till here what we have done, we have taken only one child, right? We have taken only one child to each of the number. But if you see this, after this 2, if we don't include 5, if we include 3, right? Can we include 3? Yes, we can include 3. So if I sorry, if I include, if I include 3 here, in this case, let's make this separately for 2, right? If I include 5, this will becomes nothing, right? 5 will doesn't give me anything. But if I include 3, if I include 3 here, so this will give me something, right? This can give me something. So after this 3, if I move to other approaches, so if you have seen that 3 is greater 4 is greater than 3, so this can be applicable to this, right? This can be applicable to this. So after this 3, this 4 can be applicable. So if you see this 3, the number which is greater than this 3 is 4, right? And this 2 3 4 is 3-member team. It means 2 3 4 can form a team, right? So it means whenever I got a 4, whenever I got a 3-member team, I will return 1, right? So this 2 3 4 give me 1, right? This 2 3 4 give me 1. Again for this 2 is over, but after this 5, when we have checked for each and every member, there is no any child. But after this 3 4, but after this 3 4, after this 4, there is also no child. So it means only one member is formed, which is 2 3 and 4. And here we don't need we don't need to worry about the team and its members. Team and its members, we just need to return the count of teams, right? Count of teams. So we don't need this, we just return 1 if get a any member. So the base case, if you see that, when will I return 1 from here? When will I return 1? When I can form a team of 3 members, right? A team of 3 members, then I can return 1. So the base case is something which we have, which I got till now, right? So instead of this 2 5 3 4 1, suppose I have something like 6 and 7, right? 6 and 7. So in this case, after this 5, there are possibilities, right? 6 can be present and 7 can also be present. So if I store 7 6, 1 second, right? Yeah, if I see for 6, so 6 is present, can be present, right? 6 can be present. And if I see 7 can also be present, if I don't include 6. So basically it's include and don't include possibilities, right? So here we follow include and exclude possibilities, right? We need to check for each and every possibilities. So if you see here one thing, that something is repeating, right? Something is repeating. This 2 3, then again we got 3 4, the again 2 3 4, something is repeating again and again. So if you apply brute force, it will leads to O of n cube. It leads to O of n cube because there are three ratings possible. So it means you need three different soldiers. So you need to follow each and every possibilities. But you will start from I, then you can take J, then you can take K, and check that whether is it increasing or decreasing. So brute force will be O of n cube, but here this n is given 10 to power 3 and constraint is given 10 to power 3. So basically brute force will be not approached, right? Brute force will not applicable here. So what will applicable? So if you see, this is overlapping conditions, right? If you see the recursion tree, recursion tree, overlapping condition, many there are overlappings, right? There are many overlappings. There are many overlappings, right? So one thing is for sure that we need to use memoization, and for this overlapping conditions, right? So basically if you take 6 and 7, so instead of this 2 5, there can be possible 6 and 7, right? So 2 5 and 7 uh, can form a team member, right? So we will return one from here also, right? Again 2 5 6 can form uh, a team of three members, so this can return one. So one is returned from here, one is written from here, one is written from here, and one is written from here, right? So when we have started from, sorry, when we have started from 2, I got these three for increasing, only for increasing. We are talking for increasing, right? Remember, we are talking for increasing. We are talking for increasing, right? We are not talking for decreasing, because there will be same process for decreasing also, right? We are talking for increasing. So 2 3 4, sorry, 2 3 4 not three. The members are three teams can be formed when we start from 2, right? Same cheese, same thing where which we started from 5. We will see that, right? Same thing we have started from 5. So 5 we have started, then again you see that this is something. Okay, one thing to note, that how will you know that we have got three members? So also you need to also keep track of the count, right? How will you keep track of the count? So we will start counting team members, right? Sorry, uh, I'm not feeling well actually. So 2 1 is, this is the first member, this 3 will be the second member, right? So we will start with the counting, right? This 5 will be also second member. The, this 5 will be also second member, right? This 6 7, this 6 will be the third member, right? The 7 1 will be also third number, right? So we need to store its count also, that when will how will I know that I have got the three members count? So you need to start the counting, you need to also keep track of counting with this, right? So this is 4 and this is also 3, right? So whenever you got 3 count, you will return 1, right? Same goes for 5, right? Same goes for 5. So 5 will count as 1 here, right? This is 1 here, this is second here, right? And also there is a 7 which is third here, right? This is 7 which is third here, right? So basically what is happening, that we are starting from each member 2 5 3 4 1, and we are going we are going for each iteration for 5, then 6, and we are also keep tracking that till this index, or this is this ratings, which how many team members is formed, right? And we are just using that, right? We are just using that. So basically it is just a recursion problem, basic recursion and memoization, right? If you got this, you can apply. If you have solved recursion problems or memoization problems, any recursion memoization problems, because this is now basics, this is now a basic, right? So same thing goes on for 5, right? This 5 can now this will return 1 from after this, right? Same start, you will start from 3 1, right? 3 1, and the same process will goes on. So after this 3, this 4 can be formed, right? After this 3, you have multiple options. Either you can include 4 4 2, or you can include 6 1, 6 2, sorry, 6 2. Or you can include you can include 7 2, right? 7 2. So same thing goes and goes on. And after this 4 2, either you can choose again three possibilities: 6 2, 6 3, or 7 3, right? 6 3, 7 3, right? So if you see that this is again same thing, right? This is same thing as we have done for 2, right? This is the same thing, 7 3, right? Again for 6 2, 7 3 is possible, right? 7 3 is possible. 7 3 is possible. So if you see here one thing, before this 3 1, right, this 6 2 and this 7 3 is repeating, 6 2 and 7 3 is repeating, right? 7 2 is already we have seen where we have seen here in this 5 1, because if 5 1 6 2 is also possible and 7 2 is also possible here, right? 7 2 is also possible here. 7 2 is also possible here, right? So basically if you see, we have repeated overlapping problem, 6 2 7 2 6 2 7 3. So if we solve for 6 2 anyhow and restored this position, so we can simply return from that, right? So this is the overlapping conditions we are talking about, right? So this is how we solve this question. This is for increasing, same goes for decreasing, just a greater than and less than sign, right? So let's just try to implement it. Rating dot size. Now the first thing is, there are two possibilities, increasing and decreasing. So we need to form we need to take two two D arrays for keeping track of each and every number, which is current index and the count number, right? So that would be n, and the second will be the count, which is can go to 3, 1 to 3, right? So I will take this 3 comma minus 1, right? It can goes to 3, right? So we will take 3, right? And now what we will do, we will start for from each and every number, from each and every number. And what we will do, we will store the count, right? Whatever team formed for each number, we will store that. So first number would be answer. So the first will be the increasing, right? So what we will do, we will solve for increasing, right? This is for increasing. So what we need to pass, we need to pass the current index. This that will be I. The second will be the DPI, and the okay, and this also ratings. The third will be DPI and the also account, which is 0, right? You can also take this you can also start from 1, but we have taken vector int as a 3. So whenever I got 2, I will return 1, right? Whenever I got 2, because I'm starting from 0 index, so whenever I got 2, I will return. So you can either write 1 here, but for that you need to do its 4, right? So either you can write 4 or start with 1, or the other you can write 3 or start with 0. Same thing, right? And whatever we find for this solve, the same thing goes on for decreasing purpose. This decreasing also, this DPI, instead of this DPI, i need to take I need to take this dp decreasing, right? Which is the dp decreasing, right? And we will pass this dpd here. And what will be the answers, we will return just as an answer, as a count, right? We need to know the count of number, right? The main thing is to solve this, implement this solve inc, right? So the solve inc is for increasing, right? So int solve inc. The first is index, current index. The second is rating. So we pass it by reference, right? Pass it by reference. And the third is vector int and the decreasing DPI, right? And last is count, right? That how will you know count? So the base case, what was the base case before? The base case was that whenever you got a 3 count, right, you will return 1. So here we have started from 0. So whenever I got count as 2, I will return as a 1, right? Because we have started our count from 0, our count from 0. our count from 0, right? That's fine, right? After this, if we are again checking for each and every number by excluding and including, so what we will do, we will start from I plus 1 till jn, right? And what it will do, it will check for each and every number for this I, right? And whenever I call this recursion function again, when this rating j is greater than the current rating I, right? If it is condition satisfied, we will, what we will do, we will uh, check for another term, right? It means I got a different member for this t, and we will increase our count also, right? So that would be answer solve inc, inc, and this will be I, sorry, this will be j, because the current index is changed, and now we will check for further this j point, right? The rating will be same, the dpi will be same, and the count will be increased because we have got another team member, right? And this will go on and go on, and whenever the count will return 2, it will return 1. The one base case is also that if I is greater than n, it means we don't get anything, right? We will don't get anything, we will just return 0, right? Also after this we will return answer, but before this we will memorize it, right? Before this we will memorize it by counting, right? So till this here, if you do this here, this is just a recursion function, you have not memorized it, right? So this will give tail, because it is taking checking for each and every possibilities, and there are many overlappings possible here, right? So we need to memorize it, and for memorization what we will do, we will just put it here, dpi count, store for each index and the counting from here. And also before repeating this same process, I will check that whether this dpi count, whether this dpi count is -1 or not. If it is not -1, it means this is already visited, right? This things is already calculated in my dpi account, and we will return from here. We don't check again for this, right? That's what this memorization will approach solve here, right? And the same thing, the same code will goes for solve decreasing. Just copy paste, right? Just copy paste and change the variables name and the sign, right? The same code is go with the same code with goes with solve decreasing function, right? Solve decreasing function, this will be dpd, right? And dpd, okay, here should be dpi, right? Here this should be dpi, right? Okay, one thing to note, that this needs to be decreasing, so we will check for decreasing, just change its sign, right? And this will be dpd, dpd, right? This is how we solve this problem, right? And after this we have stored all the answers and current names and just return answer. Let's run this. Hope this not give compilation error. Okay, this give compilation error. Okay, we have not defined n, which is rating dot size. Same thing for decreasing. Okay, right? So let's just run this. Okay, something is wrong here. Hmm, it is coming 3, not 2. Okay, we have started from 0. We are increasing count. When we are increasing count, this will be 2. Hmm, okay, so solved increase. I think some variables is not changed. Solved decrease. Okay, this should be solved decrease. Let's just run this. We have passed the test cases. Let's submit it. Yeah, we have passed all the test cases. So this is how we solve this question, right? So basically, what is the time and space complexity? So time complexity would be, if you see here, we have taken, we are going for each and every node, from starting from each and every node. So let's debug this, right? So we have started from each and every node, and choosing for each and every node, that would be O of n square for sure, right? So that would be O of n square, and there is we have handled overlapping using memoization. So O of n square plus O of n square for increasing and decreasing both. So overall O of n square, right? Overall it is O of n square. That is feasible, right? That is feasible. And the space complexity would be, so we have taken an extra array, two extra arrays of course. So that would be 3 times into O of n, right? 3 times O of n. We have taken an extra, right? See, we have taken this 3 into n, right? So that would be 3 into n overall time complexity for this problem. So hope it helps. Thank you so much. Bye bye.